Universal joint assembly, make a copy, universal joint assembly, Zucal. I think this is the second one, so we'll call it Zucal 2. Now you'll only see the window that I'm working with in the video. I have the slides up on another screen right now. Create an assembly tab. Plus, create assembly. Drag it over. Rename it to universal. I always feel like making words smaller, but I don't want to make the third word in universal joint assembly smaller because then it's a potty word. Assembly tab, insert the universal joint flange. Insert universal joint. See, sometimes I click things, like I double click somewhat naturally, and I have to keep looking up at the little window on the left because I like insert two things sometimes or create two things. So you got to pay attention to that. Looks like they're trying to align the thing with that. I guess I'll try to do that the same too. One of the things I said in the other video, and I'll try to remind, is when they want you to align things with the origin, trying to do it just from the isometric view does not work. You want to like have some two-dimensional views that you're doing it from. Look at it from the right, and then look at it from the front, and then either the top or the bottom. So see, now that looks like it's aligned to the origin. So now I'll go back to my isometric view.
I remember my desks and
I'm recording, just so you know.
I'm sorry.
No, it doesn't matter. You can be in the thing. Fix the instance in place. I wish somebody could just right-click on me and that's all it took to fix me. Take a lot of more work than that. Insert the 3 parts from the universal joint components part studio. Insert universal joint. Because I've done this before, it's actually feeling a bit easier. Okay, did I only put in one this time? I only put in one this time. And it looks like the picture. Now I need to mate the center block. I'm actually going to drag the center block over here so I don't get confused with other things. What kind of mate do they want? A revolute mate. That one. And it's the one that's going that way. Right? With the center of this. And that looks good. And we have to have limits. Negative 90. 90. And we accept. The axle to the bushing. I'm going to drag them apart so I do it right. They want this mated with fastened. Needs to be this face with this one, middle ring. Man, you gotta zoom in sometimes. That one, okay? They look mated properly, except the mate. Mate the bushing to the center block with another fasten mate. Fasten. You know what? It is hard to see that with this here, so I'm going to go over to here, and I'm going to temporarily right-click and hide that. Did it hide it? There it is. Now I can find the face that they want, which is this face, with that face, so they're flush. That does not look right for some reason. Maybe I didn't pick the circle. Oh, let's go back. Let's hide that again. Fastened. Oh, maybe I was clicking over here, but not the center. Yeah, I think I clicked on that. It should be this. With this. And that. And now it looks good. Nice and flush. I'm going to unhide or show that. Now they look like they fit together real well. Restructure the assembly and move the axle and bushing to a subassembly. Select the two instances in the instance list. Right-click and choose Move to New Subassembly. So these two. There's the flange. So I need the graphite phosphorus bronze bushing and the universal joint axis. And right-click and move to a new subassembly. Rename it Universal Joint Axle Subassembly. I abbreviated, doesn't matter. Now it wants you to move that to the origin. So the reason why they want you to move it to the origin is so that when you are putting it into other assemblies as a subassembly, the default where it is placed is relative to like where the zeros are, meaning you won't have to like offset it or give it other fastening if your original placement is based off of where you want it to go. Anyway, so now it says we want to click on that. Now this is the tricky part that I've gotten better at. I want to move this so it's that circle is over the origin. Why is it facing? It should be facing the other way, should it not? Huh. Well, I'm going to move it to the origin anyway. But to make sure I do it right, I'm going to look from side views, not the isometric view. Okay, pretty darn close. That needs to slide over. You definitely need a better method to doing that. the arrow's not going the way that it's supposed to go. So I don't know if that's going to be an issue. I think I'd like to flip it. Well, it says align to Z, so if I align it to Z, I need to rotate it. Which way? Okay, now it should be aligned to the Z axis. Yeah, it is, because there it is, up and down that way, and there's the Z up and down that way. Okay. Fix it in place. Almost there. Navigate back to the main assembly. Select the replicate feature. Which is here. Select the subassembly as the instance to replicate. And choose match individual faces from the pull-down menu. Then click the 3 faces on the center block as shown. Okay, so we need to click on that though, so it knows that we're selecting it. So that one, and that one. Oh look, they're on there, looking pretty good. Accept it. Copy and paste the universal joint flange to a second instance. Copy, paste, mate with a revolute so it can rotate. So, revolute this one with now there's 2. That one, oh, that one I already used. I need this one. There it is. Minus 90 and 90. Move the top flange. I moved it. Whoa, everything moves. Yay, I did it right. Although there's still interferences. I don't know if I completely agree with the limits that they put. But so be it. Check your answer. Reset both mates. This one and this one. Next slide. Select the universal joint flange 2. See, why is it starting that way? That is not the picture. Maybe that needs to be different. Really? If I hit undo, it's going to do it. No, don't do that. Let's go back and look at that. Huh. You know what? I am going to just manually rotate this puppy. 180. And I'm going to manually rotate it this way, 90. And then I'm going to do that. I don't know why, but I think that's going to help. Yeah, see, now that looks good. Solve. Oh, I didn't put those limits in. Well, those limits aren't going to affect the gradient. Are they? File answer. Reset. 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 There you go. Now move my face. Oh no, there it is. Mass properties of universal joint flange 2. Go to the self-check, John. Which is center mass? Choose the best answer. So again, I'm not going to get exactly right every time, but I'm going to look at it and say my biggest number is in the Z at 3.07 inches. Which one of these, A, B, C, or D, has the biggest one? Hold on. Let's get both of these in here for now. All right, so now we can look at it. So the biggest number, oh, there's 3.06. So that's probably it. That's correct. Ha! I didn't even have to verify the other two. By the way, there's a little SAT and other tests, multiple choice test thing. If you've got that whole thing, you know, if you're crunched on time, that's the one that fit my criteria, so that's what I went with. Okay, so that was it. It looks good, and kind of tried a few things. So now I will stop the video.